Friends, in the previous video we had seen the concept of inequalities. Now in this video let us try to solve few problems based on inequalities. So we have a statement and a conclusion. From G we need to move to D. So G is here, D is here. From G we can go to D, but as per the relation G is greater than or equals to D, but here D is less than G, so this is wrong. From K we need to move to D. So K is here, D is here. From K we can move to D and there is greater than, so it is true. The answer is only 2 follows. From Q we need to move to Y. Q is here, Y is here. There are opposite signs between them, so the relation is cannot be determined. So we get 3 possibilities. This is wrong. And from Y we need to move to E. Y is here, okay, E is here. From Y we can move to P, but we cannot move further. Again, it is a cannot be determined case, so neither follows is your answer. From E we need to move to S. E is here, S is here. E to X, X to C, C to S, but we have is equals to, so E is greater than or equals to S. Individually it is wrong. E is equals to S, we had already found the relation between E and S. This is also wrong, but when we combine these both, we are getting all the required relations and they are not repeating, hence this is an either or case. The answer is either 1 or 2 follows. So now let us see this statement. From O we need to move to P and we should have equals to in the entire path. So where is O? O is here. Where is P? P is here and P is here as well. So we need to see a connector. What is connecting O and P? So there is L, there is S. So S is here, S is here. So S is a connector here. From O we can move to L, from L we can move to S, from S we can move to K, but we cannot move further. So it is a cannot be determined case, but here only they are given greater than or equals to, hence this is wrong. From H we need to move to I. H is here, I is here, okay. So what is the connector? P is the connector. From H we cannot move further, so simply we can say this is also wrong, and the answer is neither 1 or 2 follows. So here they are asking relation between Q and S, from Q to S. So let us find where is Q. Q is here and S is here, right? So what is the connector? R is the connector, right? From Q we can move to R, from R we can move to S, and we have greater than or equals to in the entire path. As per the priority of symbols, the answer is Q is greater than or equals to S, and there is only one comparison here, so we can directly take that. So individually it is wrong, but when we combine these both, we are getting all the required relation comparisons. So the answer is either or, and they are not repeating. So the answer is either 1 or 2. For suppose if they had given is equals to here, only 2 would be your answer, right? From Z to E, E to Z, okay, and from Z to J, okay. Let us find Z. Z is here, E is here, okay. From Z we can move to G, we cannot move, so the relation between Z and E cannot be determined, so we need to have 3 signs. Z is here, J is here, right? Z to H, H to T, T to U, U to C, C to J. From Z we can move to J, but the entire path is having is equals to, and based on the priority of symbols, Z is greater than or equals to J is your answer. We need to see whether E and G are equal. If E is equals to J, then it would be a case of either or. If there is no such a thing, then it would be none follows. So E is equals to only F here, so not an issue. Neither 1 nor 2 follows. From T we need to move to A. T is here, E is here. From T we can move to X, X to M, M to A. So this is true. From O to S, O is here, S is here. O to G we can move, G to H, H to S. So this is also true. The answer is both 1 and 2 follows. T is equals to Y and Y is greater than T. So from Y we shall move to T, okay, that would be easy. Y is here, T is here, and T is here as well, right? So there are two T's. We need to see what is the connector. So W is the connector here. So we shall move from Y to W and W to T. Okay, so we get the relation is T is less than or equals to Y, or Y is greater than or equals to T. Y is equals to T, individually it is wrong. Y is greater than T, individually it is wrong. So when we combine these both, we are getting this relation and none are repeating. Hence the answer is either one or two follows. Okay, let us see few more. From U we need to move to K, from K we need to move to C. Where is U? U is here. So K is here itself. Can we move from U to K? We cannot move. So opposite signs, it is the relation between U and K cannot be determined. We need three signs, but we have only one sign. So this is wrong. From K we need to move to C. So K is here. K is here as well, but C is here only. So we can ignore this K. K to I to A to C. We can move, and as per the priority of symbols, greater than is your answer, and that is what given in the conclusion. So this is true. The answer is only 2 follows. From C we need to move to M, from O we need to move to M. Okay, where is C? C is here. Where is M? M is here. What is the connector between them? J is the connector. From C we need to move to M, C to V, V to J, J to R, R to M. While moving through the path, we have greater than. Okay, don't confuse here. From C we can move to V, V to J, J to R. Don't confuse it as lesser symbol. It is greater than symbol, right? So this statement can be written as J greater than R greater than or equals to M. So rather than writing this, when you understand the shortcut method like passage from one point to other point, that would be easy. C to V we can move, V to J we can move, J to R, R to M. This is only less than. J greater than R or R less than J. Hence from C we can move to M, and based on the priority symbol the answer is true. From O we need to move to M. So O is here, M is here, and where is other M? Okay, O to Q. From Q, see this connector. Okay, from O we can move to Q. From Q we can move to K. From K we can move to J. Okay, J is a connector. Again, another connector here. From O to Q, Q, Q to K, K to J, J to R, R to M. And is equals to is not here, and is equals to is not here. So O is greater than M. So the answer is both 1 and 2 follows. See, for this conclusion, we shall see again. From O we can move to Q. So Q is a connector here. From Q we can move to K. From K we can move to J. J is a connector in these statements. From J to R, R to M. So there is no is equals to here. There is no is equals to here. So it is true. Both 1 and 2 are true. From H to Y and Y to H. So let us directly find the relation between H and Y. Okay, Y is here, H is here. Okay, what is the connector between these both? R is the connector. H to X, and again there are two opposite signs. When there are opposite signs, as discussed earlier, it is a cannot be determined case. We get 3 possibilities. So we need to see whether there are 3 possibilities or not. H is greater than Y, H is equals to Y, H is less than Y, right? We have 3 possibilities. Y is greater than H is nothing but H is less than Y. We have 3 possibilities. Individually they are wrong and none are repeating, right? Nothing is repeating. Every comparison sign had come only once. None is repeated. So it is an either or case. The answer is either 1 or 2 follows. Now let us see for R to S and R to T. Where is R? R is here. Where is S? S is here. Okay. R to O, O to Y, O to S. So R is greater than equals to S. As per the priority of symbols, we get this relation, and the conclusion is also given the same. Hence this is true. From R we need to move to T. R is here, T is here. So the connector is U here. R to U, U to P, P to T. There is no is equals to here. Hence R to T is true. Here the answer is both 1 and 2 follows. From P we need to move to C. Okay, where is P? P is here, C is here. Okay, so what is the connector? F is the connector. P to R, R to O, O to T, T to F, F to C. But we are getting a relation based on the priorities. P is greater than or equals to C. Again, he had given P is equals to C. Though individually they are wrong, they are not repeating. Hence, the answer is either 1 or 2 follows. From K to H and K to D. So, K is here, H is here, K to L, L to E, E to H. It is moving, and based on the priority of symbols, K is greater than H is your answer. This is true. From K to D, K is here, D is here. We can move, but there is no is equals to in the entire path. Here is equals to is missing, and based on the priority, we get that D is less than K. But given D is less than or equals to K, it is wrong. The answer would be only one follows. Okay. From Q we need to move to S, from N we need to move to R, and the entire path should have is equals to. Q is here, okay, S is here, S is here, and S is here as well, okay. Q to K, so K is a connector, Q to K, K to A to S, we can move Q to K, K to A to S, so this is true, Q is greater than S. From N we need to move to R, N is here, R is here, S is the connector again, N to B, B to S, S to R, entire path is having is equals to, so N to R is equals to is there, so this is also true. The answer is both 1 and 2 follows. From F we need to move to A, from B we need to move to D. F is here, so A is here, the connector is C, F we cannot move from F to E, so this is wrong. And from D we need to move to B, right? From B is here as well, see, B is here as well, from B we cannot move further, neither from B here we cannot move. The relation between B and D is cannot be determined, okay. So we shall also find the relation between F and A as well. What is the relation between F and A? From F we cannot move to E, from E, C, so the relation between A and F is also cannot be determined. It means that there are 3 possibilities. So this is wrong, neither 1 or 2 follows. This is your answer. So from A we need to move to C, from B we need to move to D, and D again we need to move to B, okay. So you need to understand the concept, which is priority of symbols, and the shortcut method. Like shortcut method is generally used to see whether it is moving or not, and in the back end of your mind you need to find the relation as well. That means we need to move from A to C, right? A is here, C is here. From A we are moving towards B, B is the connector. From B we can move to C. While moving we need to check the relation. Based on the priority of symbols, we get that A is greater than C, okay. So this is true. And for B is equals to D, B is here, D is here. See, in this statement B and D are available, so we can extract the relation between B and D from this directly. Based on the priority of symbols, we can say that B is greater than D, but here given B is equals to D, so this is wrong. So the answer would be only 1 follows. If you didn't see the first video of inequalities, please do watch it, so that you get to understand how I am solving all these things. From R we need to move to M, from S we need to move to Q, and the entire path should have is equals to. R is here, M is here, R to T, T to Q, Q to M we cannot move. Opposite signs between them, the relation between R and M is 3 possibilities, but they are given only single possibility. This is wrong. S is greater than or equals to Q. From S we need to move to Q. So S is here, R is here. S to R we can move, greater than or equals to. R to T we can move, T to Q we can move, and the entire path is having is equals to. So the relation between S and Q is S is greater than or equals to Q. So second one is true. The answer is only 2 follows. From S we need to move to M, from M we need to move to S. So we shall directly find the relation between S and M, as they are common in both the conclusions. S is here, M is here, okay. So the connector between S and the one statement, this path and this path is P. So from S we can move to R, R to Q, Q to P, P to O, O to N. But from N we cannot move to M because of opposite sign. So the relation between S and M is this. We have S is greater than M, okay. S is equals to M, okay. S is less than M, we have. Though individually they are wrong and neither of them are repeating, okay. The 3 conclusions, the 3 possibilities are coming only once, hence the answer is either one or two follows. From A we need to move to C, from E we need to move to C. Okay, A is here, C is here, A to B, B is the connector. From A we can move to B, from B we can move to C. The answer is A greater than C, which is C less than A. This is true. From E we need to move to C. E is here, C is here, D is the connector now. So from E we can move to D, the path has is equals to. From D we can move to C, the path has is equals to. So E is greater than or equals to C is your answer, which is given. So the answer is both 1 and 2 follows. From S we need to move to W, from W we need to move to T, or from T we need to move to W. Okay, now let's see this. So S is here, T is here, right? S is here, okay, W is here, sorry. S to T we can move, T to U we can move, U to W we can move, but the entire path is having is equals to, and based on the priority of symbols, the relation between S and W is S is greater than or equals to W. But they had given only S is greater than W, so it is wrong. From W we need to move to T, or T to W. Okay, let us see where is T. T is here, W is here. Okay, so S to T to U you can move, U to W you can move, but the relation between T and W is T is greater than or equals to W. But here they are given T is equals to W, so this is wrong. When such a thing is given, if in the statement they had given S is equals to T, right? They had given S is equals to T. If you see these both statements, it means that T is greater than W. First conclusion can be written as T greater than W, and second conclusion we can write it as same, T is equals to W, and the relation between T and W is T is greater than or equals to W, right? So when is equals to is given, we need to check for either or case in such examples. So this is an important example. See, though S is greater than or equals to W, this is wrong. T is greater than or equals to W, individually this is wrong. But in both the cases W is common, and we need to check the relation. If S is equals to T, then we have either or case. So S is equals to T has been given here. So this first conclusion can be transferred transformed to S is equals to T means T greater than W. T is equals to W. So what we got the relation between T and W is T is greater than or equals to W, right? When you combine these both, we are getting the relation and they are not repeating. So the answer here is either 1 or 2 follows. This is very important. Okay, from D we need to move to G, and from G D. So we need a relation basically between G and D. Okay, just find out G and D. G is here, okay, D is here, okay. So from G, how to move to D? We can move to H, but there is no H here. From G we cannot move to C. From C to E, E to K, K to D. Okay, so G cannot move to D as they are having opposite directions. Hence the answer is cannot be determined. So when cannot be determined condition, there are 3 possibilities. We are getting G greater than D as per second one. Individually it is wrong. G is equals to D, G less than D. Individually it is wrong. But when we combine them, it is a case of either 1 or 2. So H to Y, Y to H. Okay, we just need the relation between H and Y. H is here, Y is here. The common, this is the connector. Okay, H to X we cannot move, X to R we cannot move, R to F, F to Y. So the relation between H and Y is cannot be determined. We need 3 possibilities, but they had given only 2 possibilities. Hence they are wrong, and it is a case of neither 1 or 2 follows. Okay, so this is some different question. Which of the following set of symbols should be placed in the blank spaces in order to complete the given expression in such a manner that V is less than Q definitely holds true? It means that from Q we should be able to move towards V, right? So Q is here, V is here. We need to find comparison signs such that from Q we can move to V. So from left we need to move to right. From left we can move here, but we cannot move further. From left we can move to right, and from right, this is a case. Okay, as there is no greater equals to, we don't need equals to in the entire path. This is your answer. When we check other as well, we cannot move here. Okay, we cannot move up to N. So the answer is B. So as per the question, we need to move from Q to V. Okay, Q is at the left end, V is at the right end. So we need to see three symbols or comparison signs such that we can move from Q to V. So these three symbols fit in such a manner that from Q we can move to T, from T to P and P to V. And also based on the priority of symbols, this would be your first priority. So the answer is Q greater than V. So this holds true. Q greater than V is nothing but V less than Q. So B is your answer. Let us see another question. Which of the following expression is true? Which of the following expression is true? If the given expression is true. So this is a statement which is true, and we need to find which conclusion or which option is correct. R is equals to V. R is here, V is here. Opposite signs cannot be determined. R is not equals to V. From N we need to move to T. N is here, T is here. Again opposite pairs cannot be determined. From M we need to move to R. M is here, R is here. M to T, T to S, S to R. We can move, and based on the priority of symbol, this would be our priority. R is less than M is nothing but M greater than R. This is true. Let us check for this as well. From V we need to move to S. V is here, we cannot move opposite signs, so wrong. That's it. The answer is this. None of this is wrong. Similarly, which of the following symbols should be placed in the blank spaces? Okay, so we need to find these two signs in order to, in such a manner that N greater than L. From N we need to move to L. From N we need to move to R. N is here, we need to move to L. No equals to here. So here the correct fit is greater than. From N we need to move to R. N is here, R is here. Here they have is equals to. So this would be your correct fit, because from N we can move to M, M to S, S to R. So we need to see this as the answer. First would be your less than sign, second would be your greater than sign. So this is your answer. Now let us see what is asking. Which of the following conclusion is false? So that's the reason we need to see the direction. If the given expression is true, so this is true, we need to find which is false. Okay. E to G, E to F, F to G. This is true, but here it is asking which is false, hence it is wrong. Okay, from H to G, and the entire path should have is equals to H to G. Okay, so this is true, but we are asking false, so this is not our answer. From H to F, H to G, G to F, we cannot move, so H is greater than, less than, or equals to F. So this is false, which means this is our answer, right? Let us check for another. I to G, I is here, I is to H, H to G, entire path is having is equals to, this is correct, but here we want only false answer, so this is wrong. Hence our answer is only 3. See, he is asking which of the conclusion is false. These 3 conclusions are true, only this one is false, hence this is our answer. Okay. Which of the following expression will be true if the expression is definitely true? Which of the following is true? This is definitely true. Okay, O to T, O to A to S, S to T, we cannot move, so this is wrong. From R to S, R to O, O to A to S, this is true. From T to A, T to S, S to A, wrong. S is equals to O, this cannot happen. S to A to O, no. R to T, R is here, R to O, O to A to S, no. So this is your answer. So coded inequalities is also a concept. Generally these type of questions come in mains. They won't ask in prelims because it is time consuming. So if you want to try, you can try this. Or let me explain one example for this. So to solve these type of questions, you need to write priority of symbols, right? It's like for solving easily. What is saying? A at the rate B means A is not greater than. Not greater than means less than or equals to. So at the rate would be for less than or equals to. Exclamation mark is A is greater than B. So this would be your exclamation mark. A star asterisk B means A is not less than B. Not less than means greater than or equals to. So asterisk would be for greater than or equals to. A percentage B means A is less than B. So percentage would be for A less than B. A hash B means A is neither greater nor less. Sorry, it's less. Okay. Means is equals to. So hash would be for is equals to. Now let us see the statement. M hash, we don't bother about this. Directly let's jump into the conclusion. So what they are saying is h is equals to k. Okay, m star g is nothing but m is greater than or equals to g. So from m we need to move to g, right? So for moving towards g, m to h, h to g, this is a possibility. From m we can move to h because exclamation mark is greater. Or if you are confused in such a way, just transfer all these comparison signs in respect to symbols. So you can write this and do this. This is not asked in prelims, just for your understanding I am giving. In the mains, while I shall do the mains playlist, I shall explain you again. Okay, h is equals to k, m is greater than or equals to g. So the statement is now transformed to this, conclusion is transformed to this, h to k, k to h, h is equals to g they are saying. So from h we can move to g, but from g we cannot move to k, so this is wrong. From m to g, m to h, this is h, huh? Okay, sorry. Okay, h to g, did I do a mistake? Okay, m to h, yeah, that's it. H to m we cannot move, m to k we cannot move further. Okay, this is wrong. From m to g we need to move from m to g, and the entire path should have is equals to m to h we can move, h to g, it means that m is greater than g, hence this is also wrong. Similarly you can do this, but this is not necessary in prelims, so that's the reason I am not going deep into this. By this we have finished our inequalities topic. In the next coming videos I shall discuss about syllogism. Thank you, stay tuned for more.